Good morning, everyone. I'm sure everyone can hear me okay. If you can't, well, how would you know? Um, so I'm David Savage. I'm going to give you a talk today on new features and updates in RouterOS. Before we start, I don't know how long this presentation is going to go on for. I've already, if I do go over the time, apologies to Hannes, who's coming up next, but I've already spoken to him about it, and I'm sure we're fine. So I'll just go until either I finish or they chuck me out, one of the two. Just very quickly, a little bit about MikroTik SA. So MikroTik SA is an independent network specialist company. We're not owned by or affiliated to MikroTik Latvia in any sense, except that we are official training and support partners for MikroTik, as are a number of other training and other companies. What we specialize in is pretty much all forms of wireless and wired networking technologies. We offer high-speed point-to-point links, carrier-independent backbone services, high-availability SLAs, and then also general network management and configuration services. So, if you need any kind of expert consultant to assist you on your network or anything else involved in MikroTik, then we're your guys. The only thing we don't do, as I might mention now, we sell hardware, since there are already many great companies that do that at very competitive prices. A little bit about myself. I'm a MikroTik certified trainer and consultant. I don't really install and manage wireless networks myself anymore, but I run a company that does just that. I have many years of experience in the IT field. I've been using MikroTik pretty much since its inception, and I teach general networking and MikroTik RouterOS. So I use the product every day, both in the office, out in the field. Loads of both technical and practical knowledge on the product. So I think I'm a pretty good candidate for giving you these updates on what's new. So what is this presentation all about? Well, as you probably know if you've used the product, MikroTik is under constant development. They're always bringing out new features and always bringing out updates to existing features. Nothing more fun than giving a training class, telling everyone how MikroTik can't yet do this, and then finding out it does exactly that because they've brought it out in the last update. So, I mean, I guess on my side, a little bit of extra reading on the changelog wouldn't work every now and then, but it's also always nice to have a little bit of a surprise. So it is difficult to keep up with new features and improvements that have been made to current features. So I hope to change a bit of that and bring you up to date with just some of the new features. This is nowhere close to all of them. I could spend probably the whole day just telling you about features you probably haven't heard about that yet, but I just put in a few interesting ones, and hopefully you'll gain some additional knowledge from that. Afterwards, there will hopefully be time for a little bit of question and answer. I have to warn you ahead of time, if there are any questions I don't know the answer to, all I'm going to tell you is it'll be fixed in version 7. So just to kick off with a few issues, I've presented some of them as a kind of problem and solution type of scenario. So the first issue is the previous version of RouterOS Backup was vulnerable in terms of the way it encrypted the backup file. So, I mean, I even saw it get down to the point where there were websites you could go online, upload a copy of your backup file, and it would retrieve usernames and passwords out of that. So a clear security risk there, and that has been fixed since RouterOS version 6.13. So since 6.13, the backup is now encrypted with RC4, if that's what you would like to do. And the backup file will be encrypted by default if you are logged in with a user that has a password. So if you're logged in as the default admin account with no password, you create a backup file, no encryption will happen on that file because it uses the password itself as part of the encryption. So, but if you're logged in with a user that has a password, then by default that user password will be used for the backup encryption. So you can see the backup file is encrypted by default. There are a few options there if you just look at the graphic at the bottom. So as well as being able to specify the name, you can either leave the password field blank, which will encrypt it with your current login password, or you can specify an alternative password if you don't want to have to tell somebody else what the password is needed to restore that backup. Optionally, you can use the don't encrypt option at the bottom. Of course, that would be dangerous if your backup file contains any usernames and passwords that might then be exposed inside the file. However, if this was a backup that you were sending to somebody else and there was no sensitive information inside, then by all means you can use the don't encrypt option, which will allow it to be restored on the other end with no additional password. In order to restore the backup on the other side, either you must be logged in as the same user who created the backup, or when you restore the backup, you will specify the password file, and that would run through the restore process in the normal way that you would expect. Then another issue that you might come across is you might want to give end users some kind of or some level of access to the router OS device. After all, I mean, they have bought the device. Even though you might be managing it, they might want to see various parameters that are installed. However, you don't necessarily want to expose them to the full complexity of the router OS system, since, I mean, that could be quite daunting for somebody who's completely new to the system. So one option you can use is, if you run the WebFig system, which is of course router OS's web management system, then you're able to apply an overlay or a skin to the WebFig system in order to expose less of the router OS management. I'll just run you quickly through the steps that would be required in order to use the WebFig with custom skins. Step one then would be to log into the web interface with an admin account, and then you can select the WebFig option. You'll see I've highlighted it with the red box at the top. Once you're in the WebFig system, then you'll see down the side there is a design skin menu that you're able to choose. Once you choose the design skin menu, you'll see the layout of the menu will change. Now you can see I have these checkboxes next to all of the current menus, as well as for each current menu, for each of the sub-menus, you can select options as you please. So what I can now do is select and deselect any items that I want to. I can also rename items. So you can see instead of calling it wireless, I can now call it Wi-Fi, or if there's anything else you want to perhaps rename for whatever reason, you're able to do that. So you can run through every single component of every single menu and select and deselect that as is required. Okay. Then, so again, you can see just in interfaces, for example, I can even drill down in finer detail to select and deselect whatever it is I want to. Once you're done with that, you'll see there's a spot there to specify a new name for the custom skin that you just created, and then you're able to save that skin under a different file name. If you're interested, that will appear as a JSON file under the skins directory of your existing router OS drive. So if you go to your router OS file system, you'll see there'll be a skins subfolder, and any skins that you create will appear in that subfolder. It is then possible to copy that skin from that router, transfer it to any other router you want to, and that skin will be an available option on any other router in your network. Once you have created your custom skin, it's then a matter of going to System Users, and in the Users selecting the Groups subtab. You can see then from the Groups subtab on the right-hand side, I have created a very limited access user. Specifically, I've only given that user read and web access. What I need to make you aware of right from the beginning is that the skin only applies to the web interface. So if you create a user that also has Winbox rights, and the user uses Winbox to access the router, they will have access to all the interfaces. So that skin won't apply in Winbox mode. So it does make sense to limit that particular login down to just specifically web access mode. And read access is, of course, required for any kind of access to the router at all. So that's the minimum level of permissions you'll need to give. In addition to that, where it says skin at the bottom, you'll see I've specified the web skin that I'd created earlier on. So that's how we apply that skin to that particular group of users. Once I've created the new group, the next step is to create a new user. And you can see I've created a user just called Web, and I've assigned him to the Web Limited group. If you want to optionally, as with any other user, you can limit the range of IPs that account may be used from. So once I've created my group, I've created the user that belongs to that group, and of course in the group I've specified the limited skin. I can now log in with that new limited user, and as you can see, it's given him a very, very strictly limited view. A few things I've changed. Instead of saying wireless, I've now called it Wi-Fi. Under interfaces, you can see here I've limited it to only interface and Ethernet, and in addition to that, given him a very, very limited sub-menu. So for example, in the tools menu, I could limit him to just doing ping and traceroute. If I don't want to allow bandwidth test or flood ping as an example, I can remove those completely so that the user is not exposed to those menus at all. One of the great features of root roads, which has always been a very powerful management option, is the ability to manage the router directly by its MAC address. So that's always been a fairly big deal for me. The fact is, you can access the router with no compatible set of IPs between your device and the router itself. The limitation for that, though, has always been that you needed to be directly connected to the router. So either you plugged straight into a router ether port, or you plugged into a switch that's plugged into the router, or you connected to the router's or one of the router's WLAN interfaces. Whatever it comes down to, you'll need a direct layer 2 connection to that device. If the router is located across several other routers in a layer 3 traditional routed network, then you won't be able to see that router by its MAC address. Okay, that's a very common limitation. A great solution to that, though, is to run the RoMON system, which is the Router Management Overlay Network. What RoMON does is effectively establishes an independent MAC layer peer discovery system and also data forwarding network. So the RoMON system is completely independently established. It doesn't care whether you run in layer 2, layer 3, or anything else. As long as all of your routers are connected to each other in some way, they can set up the RoMON service between them. So a completely independent management layer that doesn't depend on any other protocol at all. So it's a completely built-in protocol. In order to allow RoMON on your network, there's a couple of steps you need to follow. First of all, inside Tool and RoMON, you need to enable the service. So you can see at the top there, I've clicked on Enable. You can optionally specify an ID per router. The ID will look like a MAC address. So if you want to number your routers from all zeros 1 up to whatever number, you're able to do that. Alternatively, if you don't specify an ID, it will just take the MAC address of your Ether 1 port, or I suppose if there's no Ether 1 port, whichever is the first available port, and install that as the ID instead. You can see there the current ID was just whatever I had on the Ether 1 port at that time. You can leave the secret blank, in which case it will set up a sort of plain text RoMON connection between devices. Otherwise, if you want to ensure that your device cannot RoMON with anything outside of your network, which might be a fairly obvious danger, you can specify a RoMON secret. So that'll just use MD5 between routers and ensure that they only connect to other authorized routers and devices. In addition to that, by default, RoMON will run on all ports. However, there is a ports button down at the bottom. Sorry, I hope everyone on that side can also see. I can only point to one side at a time. There's a ports button, and inside there, you can specify the behavior for specific ports. So you can allow and disallow specific ports from using the RoMON service. You can also set up independent secrets on a per port basis if that's what you need to do. So if we just look at a standard setup, if I went to, so I'm just going to bring my Winbox over here, went to a normal router, go to neighbors, and you can see the only neighbor that's coming up there is the access point that we're all currently connected to. Yeah. So instead of doing that, what I can do is once I have the RoMON service running on all my devices, I can use connect to RoMON to connect to my network and expose all of them instead. Now, I hope this demonstration is going to work. I'm not connected to my network at all from my laptop currently. So this laptop is connected to the Hilton's guest Wi-Fi system, and there's nothing there whatsoever. So just to show you the power of RoMON, I'm going to connect to a router that's currently at my house. It is on a public IP address, and I'm allowing Winbox into it externally, and I've done it just to illustrate to you how powerful the RoMON system is. So what I'm going to do here is just run over to my managed routers. Let's come up there. I'm going to select the router that's in my garage, and I'm now going to say connect to RoMON. So this is over the internet, independently establishing a layer to connection to my network, and then exposing all my devices via layer 2. Okay, so you'll see I can click on any one of them, click on connect, and that is now connecting by a MAC address across the internet to a router inside my network. Okay, you see I can do interfaces, check out anything I want on the router, manage it in any way that I want to. So I think the obvious questions around RoMON is around security. Isn't this very insecure or anything like that? So just to set your mind at ease on that, first of all, in order to connect to the RoMON service, you need to have the RoMON permission as part of your user. So if I can just connect to another router in my network. So you'll see under system users and groups, if I open up any group, there is a RoMON permission. So the RoMON permission must be supplied to that user in order to allow him to connect to the RoMON service. In addition to that, as well as having the RoMON access right, you need a valid username and password for that router just to connect to the RoMON service. Once you've connected to the RoMON service and all your other routers are exposed, to connect to any other of those routers, you also need a valid username and password for that. So I don't think RoMON adds or subtracts any level of security from your system. It's just a different way to expose your routers for management purposes. So the only way anyone could connect to RoMON is if they had the username and password for your router. And if they had that, I think your problems are a lot bigger than somebody connecting to the RoMON service. Okay, you've got far bigger issues in your network there. Okay, so that's just an illustration again of connecting to the RoMON service. I want to bring you up to date then on a few new developments on the wireless side of things, and that's mainly around the WPS application and also the very, very new experimental NV2 sync mode, which is one of the things that's been exciting me quite a bit. On later versions of Router OS, you may or may not have noticed, if you look at new products like the WAP ACs, the CAP devices, most of the little desktop routers, you might have noticed the WPS button, either on the side or on the front. Sometimes it shares duty with the reset button. So if you see something that says RES/WPS on the front, that is the WPS and reset button. So the way it works is, while the router is powered off, if you hold the button down while powering it on, that will enable the reset mode. So that will reset the router. If the router is powered on, then that acts as a WPS button instead. So while the router is powered on, WPS mode will be enabled when you press the button. So the WPS system is just a convenient way to allow access to your router's Wi-Fi AP without having to supply a password to whoever wants to connect to the system. The way it works is, with any mobile device, laptop, phone, or whatever that supports WPS, the device will attempt to connect to the router. You will push the WPS button on the front of the router. That will turn on WPS mode for up to 2 minutes or up until a client connects to the system. Once the device connects, WPS mode is then disabled, and to connect any additional devices, you will press the WPS button again. So the button needs to be pushed each time a client needs to connect. That will allow the client authentication without having to physically give somebody your Wi-Fi password, which could be quite convenient. Then router OS devices might have, as I said, a WPS button on the actual device. If they do not have a button on the device, they would also have a virtual WPS button in Winbox. So if you go to Winbox, under your wireless interface, you'll see a WPS accept button. You can use that button to also activate WPS mode. You can also, from inside Winbox, set how you want the WPS mode to work. So you can disable the physical button if you want to and allow WPS only through Winbox. Or alternatively, you can disable the WPS access completely. So that's completely up to you how you want to manage that. Next I want to examine is the NStream version 2 or NV2 protocol. So first of all, just a little bit of history. If any of you have used MikroTik's wireless device, especially in any kind of outdoor scenario, you've no doubt used the NV2 system. So NStream version 2 is based on TDMA, which is time division multiple access. And what NV2 does is tries to solve some of the problems that are inherent with the 802.11 system. And we're mainly talking about things like the hidden node problem, ACK timeout problems, and a number of other issues, especially in outdoor and long distance point-to-point and point-to-multipoint environments. 802.11 is essentially a contention-based system, so all clients connected to an 802.11 AP essentially fight it out with each other to try to gain time to the access point. NV2 turns that around by allowing the AP to specify exactly when clients may send or receive data. So what it does is takes a time slot, usually 2 milliseconds, divides that up into 512 different slots, and then tells each client when they may transmit and receive. So each client knows exactly where their time slots are and what they're allowed to do. Of course, if a client doesn't need to send or receive, it can hand that back to the access point, and the access point can reassign that out to clients that are currently using data. It also has a lot of other interesting features, such as built-in quality of service and a number of other improvements to both point-to-point and point-to-multipoint environments. It's not that I don't want to go into NV2 itself too deeply. I mean, it's already been around for a while. I'm sure a lot of you are using it on the network. What I do want to cover is a very new feature, which is NV2 AP synchronization. So since I think it was version 6.40.3, MikroTik introduced a brand new feature. It's still a little bit experimental, so just be warned that you may have unpredictable results, but I have tested it out a few times with a fair amount of success. And what this does is it lets multiple MikroTik NV2 APs, especially at the same location, coexist with each other in a better fashion by trying to reduce interference between devices. So what it does is effectively synchronizes NV2 across all the different access point devices connected to or in the same physical location, and in that way allows you to cut down drastically on interference between devices, and if you want to, you can even use the same frequency on all the devices at the same time. Since each device will synchronize its sending with each other device, we will never have a situation where two devices are trying to transmit on the same frequency at the same time. In order to do NV2 synchronization, you need to select a master access point, and you need to choose your mode as NV2 sync master. Perhaps what I can do is just log on to one of the devices in my network. This is just an SXT AC so once again at my house. You can see I do a lot of experimentation from there. So we go to wireless and select WLAN 1. Just going to go to the NV2 tab. Sorry, I'm not too concerned about the password. It's not that big a deal. So you can see I've got mode here, which is dynamic downlink fixed downlink, sync master, and sync slave. So if I select sync master, I'll get to downlink ratio in just a second. I can select sync master, a sync secret, which is what you'll need to provide on all the slaves in order for them to connect to each other. And then on each of the slave mode devices, which are on the same physical network, you will need to select sync slave. Okay. So what that will do is each of the slave access points will sync themselves to the sync master, and they'll then start syncing their transmissions to and from each other. Okay. I think what I especially like about this is, unlike AN other systems, whose names I won't mention, there is no need for any kind of GPS device. So there's no special GPS edition of it or anything like that. This will work across any MikroTik router with wireless. Just upgrade it to the latest version of Router OS, and it's available for you. Okay. One of the great things about how MikroTik do things is making everything backwards compatible through all the previous versions. So that will allow them to sync with each other. Another very interesting feature is the ability to specify a downlink ratio. So by default, NV2 sets a ratio of 50-50. So roughly half the time slots are dedicated to sending data, the other half is dedicated to receiving data. But now, with the new feature, you can specify a ratio, and you can bias the downlink or uplink in any way that you want to. So if you want to dedicate more bandwidth to download or more bandwidth to upload, you're able to do that. Or another very common situation is you might have a connection where, because there's less interference on one side than the other, your download is much better than your upload, but you need more synchronous type of data. So you can bias maybe 60% to the download if that is poorer, and it'll allow the access point to spend more time on the downlink ratio rather than uplink. So you can manipulate that in any way that you want to. If you just want to use the downlink and downlink bias, you can select either dynamic or fixed downlink. Fixed downlink fixes it at a specific amount. Dynamic tries to determine when the connection is overloaded, and then tries to dynamically shift it in any particular direction. So I've just put a little demonstration here. This is exactly that link that I've just shown you. So to give an idea of the situation, it's a router board SXT on each side. The link distance is roughly 2 kilometers. And you can see by default, with the downlink ratio set on 50-50, if you look at the band on that side, you can see it's roughly, so it's about 66 and 55 up and down. So not too far out of alignment. I mean, it's you can see I've just done a UDP full duplex test to demonstrate how that works. So we're getting about 100 and 120 megabits per second in terms of aggregate data. So what I've then done is just switched it around a bit and tried to bias it in one direction. So on the next slide, you can see I've set the downlink ratio to 80, and you can see the transmit has now jumped up immensely. So I'm running 120 plus on the transmit and around 13 on the receive. So it hasn't changed the overall amount of bandwidth I have available. Still in that 120, 130 megabits per second region. However, it's spent more time on one of the directions. So perhaps if you running your wireless in some kind of CCTV environment where you need more download than upload speed, might be quite useful to have something like that. Or, as I said, in situations where your download is much better than your upload and you want to provide more time slots to the upload portion of the link, you're also able to do that. Moving off wireless, just want to talk a little bit about VPN systems. If you are running MikroTik as a VPN server, first of all, MikroTik makes a great VPN server, and it supports pretty much every type of VPN technology that's out there. So you've got L2TP, PPTP, SSTP, OpenVPN, all the options are available to you. First of all, though, generally speaking, most people use PPTP and L2TP because that's supported across a huge number of platforms. So every single device out there that has access to VPN technology will be able to use one of those two. One of the problems, though, is they still use the very, very old MPPE 128 standard of encryption. That's the Microsoft point-to-point encryption standard at 128 bits. Very, very old encryption, quite easily crackable, and not very secure by modern-day standards. The alternative to using that is, of course, you could use either OpenVPN or SSTP, the Secure Socket Tunneling Protocol. So those are based on TLS, transport layer security, or a number of other encryption methods. Much, much stronger authentication and encryption methods. However, the problem with both of those is if either your server or your client is not run in MikroTik, you will require client and server certificates. So that's an additional layer of administration. You need the certificates on each side. They need to be verified. They need to be installed, and so on. An interesting alternative then is to use the L2TP service, but enable IPSec encryption, which is now available on newer versions of Router OS. So we talked the presentation before me talked a little bit about IPSec and how it supports hardware acceleration on certain platforms and various other advantages of using it. So IPSec is essentially a set of protocols that secures communication at the IP level. So I mean, it was originally developed alongside IPv6, but also backported to IPv4 along the way. What it does is provides encryption to the IP protocol for both v4 and v6 connections. The great thing about IPSec is it's an extensible protocol. In other words, it can be upgraded and changed all the way. So there's constant development on it, constant improvement on it, better forms of encryption, better ways of initiating connections, and so on. So we're constantly seeing updates to the system. If you watch the MikroTik changelog, you'll see with every few releases, there's improvements to the Internet Key Exchange system and other improvements to IPSec that happen along the way. So as vulnerabilities are identified, they can be patched, changed, improved on, and fixed along the way. So getting back to L2TP, with MikroTik, you can now specify IPSec as part of your L2TP system. So this is great for what we would term road warrior connections. In other words, remote devices, mobile devices, laptops, mobile phones, or whatever you like, connecting to your L2TP server. So when you specify your L2TP server, you can now enable it, and as part of it, you can specify that it should use the IPSec protocol. You have three options, therefore, use IPSec. Either no, which means don't support it at all. You have yes, which means allow IPSec, but also allow connections that don't have IPSec enabled. Or you can have required, which means only allow incoming connections that also use IPSec. Once you've enabled that requirement, pretty much any client that supports VPN will have an L2TP with IPSec type of option. So you can see I've enabled IPSec, I've set an IPSec secret, and I just took a screenshot from my Samsung phone. You can see where when I went to add VPN, one of the options was L2TP IPSec with PSK. PSK is pre-shared key. That means a password will need to be supplied. Specify the server, specify the L2TP secret, specify the IPSec secret, and that will initiate the L2TP connection and then run IPSec for much better encryption standards over that. You'll also see in the right-hand side corner, if you're running MikroTik as the L2TP client, the MikroTik L2TP client also supports native IPSec as part of the setup. So that's great in terms of allowing incoming connections into your network and also encrypting them with a far stronger form of encryption. What's even more exciting though is MikroTik has also updated all of their simple tunnel types. By simple tunnels, I mean tunnels that don't have any form of authentication and before this didn't have any encryption. So as far as IP and IP, GRE, and EOIP, and that applies both to the v4 and the v6 versions, they now all support the ability to be encrypted with IPSec as well. So to do that, you would set your tunnel up in the normal way. specify your local and remote address. Just note, usually with something like EOIP, you wouldn't have to specify a local address. However, if you are using it with IPSec, then local address and remote must be specified, since the IPSec encryption has to happen between a source and a destination endpoint. So it's going to be required. All that I need to do then to enable the IPSec service is just specify the IPSec secret. Okay. As long as that matches on both sides, the tunnel will be initiated, IPSec will be initiated across the tunnel, and everything running through the tunnel will be encrypted as well. And just if you're wondering about performance, on the few tests I've run, I've seen no discernible difference between a standard EOIP tunnel and one that's encrypted with IPSec. So there's virtually no performance deficit through using a system like that. While we're on the subject of VPNs and dial-up type connections, if you are running MikroTik with any kind of client that is giving you a dynamic IP address, so that would be a DHCP or a PPPoE client, then a very common problem is tracking what your live IP address is installed on that router. Since, of course, that address may change from time to time, and very often does, you'll want to be able to keep track on that. So past solutions included running some sort of dynamic DNS client, but that would usually need to run on some other device inside your network, whether it be a Linux-based DIN DNS or Windows-based DIN DNS client. There are also some scripted solutions available to run DIN DNS on the MikroTik router, but then, of course, you need a DNS account with a DIN DNS or whoever it might be. An alternative to that now is to use the IP Cloud service. So IP Cloud is a free service from MikroTik that will translate your public outgoing IP into a dynamic DNS name hosted on the MikroTik Cloud service. Since the name is taken from the router's serial number, it provides a very predictable way of figuring out what that name is going to be. So you can see on my router, I have enabled the dynamic DNS client by going to IP Cloud. You can also optionally, if you want to, use it to update the time on your router. So it will geolocate your region and then try to update the time in that way. And you'll see if you look at DNS name, the DNS name is the serial number of the router .sn.mynetname.net. Okay, it'll update it. If there is a live IP on the router, it'll run through it no problem. If the router does not have a live IP, it will still work. However, it will give you a warning back telling you that the connection was initiated from a private IP, but the update came from a live IP. So clearly there's some NAT involved in that network somewhere along the way, and you might need to put in some reverse NAT entries in order to get that live IP back to the router. In terms of the firewall, a few changes made to the firewall that I'd like to point out as well, and that is mainly address list by DNS name and also improved methods for adding addresses. How am I doing on time? Still good? Well, nobody's objecting, so we're okay. A very common previous problem with MikroTik is what happens if you want to apply a firewall rule, but to a DNS name. So previous solutions might include having something like a layer 7 filter rule, which is workable. However, a layer 7 rule takes up a lot of firewall resources. So you're really going to stress your CPU out by having any kind of rules that's examining layer 7 or application layer data. So with later versions of MikroTik, it now directly supports having DNS names inside firewall address lists. So instead of specifying an address list name and an IP address, you can now specify the list name and a DNS name. The router will then do a dynamic lookup on that DNS name and use that to dynamically populate your address list inside your address list tab. The address list will be refreshed according to whatever TTL is provided from upstream. So if it gets the address with a TTL of 3 days or whatever it is, then every 3 days it will ensure that it goes out and refreshes that address from time to time. The other great thing is if you have domains with multiple servers or multiple IP addresses, it will update with all of those addresses at the same time. You can see here as an example, I've specified netflix.com as the address that I want to track, and that in fact has come back with multiple server entries. So it's come back with all the Netflix domains, and it will continually update that according to whatever TTL was supplied by the Netflix DNS servers. Another very common feature used in Firewall is adding either source or destination addresses to an address list. So previously, you had the option to add it to an address list, and it would add it as a dynamic entry. Further on down the line, the option was also included to add it as a dynamic entry, but with a timeout value. So you could add it in for whatever you might want, 10 seconds, 30 seconds, or whatever it might be. That has since been updated to give you even more options. So you'll see now, when you update or when you add an address, you have an option of specifying a specific timeout value. So I could put in, say, 30 seconds. Otherwise, I can specify non-dynamic. So what that will do is add a dynamic address list entry, but with no timeout value, which means it will stay there for as long as the router is booted up. The other option, which is quite nice, is the non-static mode. And what that will do is it will add that address in, but as a static entry. So if the router is rebooted in future, then that address will remain behind. So if you're using it to try to track some addresses, even if somebody reboots the router along the way or it loses power, whatever it might be, you won't lose access to those addresses in any way. Okay, that's all I thought I had time for. If there are any questions on any of that, please ask away. Okay, no questions? Everyone happy? Well, yes. Hi. Correct, yeah.
So, but the way you showed it here was between a point-to-point system, am I correct?
Sorry, no, there might have been some confusion. It's exactly as you said. You have multiple access points on a common site, and you're trying to reduce interference between those access points and sync their communications with each other. So that is how it works, yeah.
So that's how, so it's between access points?
Correct, between access points, yes.
And the frequency can be different as well as the SSID?
Yeah, it doesn't matter. It just looks at this, it just checks the secret and syncs them. Yeah. Yes. Sorry, he had a question first. Yeah.
Basically, then same stuff. Different providers could all play friendly then on our side.
Potentially, yes, that could happen if they have connectivity to each other. Please go ahead.
Sorry. Okay, so Apple, in their infinite wisdom, blocked PPTP, even forwarding through their phones and all sorts of stuff. L2TP, this doesn't just work on Windows if you're going to use secrets and stuff. What are people doing? I mean,
So I don't know what you mean by L2TP doesn't work on Windows.
well, L2TP going through a hotspot on an Apple device, for example, isn't as easy as it used to be with things like PPTP. PPTP now was just blocked on Apple. Now you try and do L2TP and you want to use secrets. I just wanted to know what are other people doing there? Samsung.
There you go.
Director has an Apple product and we're stuck there. Now they're used to just using Windows and going through the wizard and there their VPN works. Now it's a nightmare to connect people like that.
Yeah, the only difference is on Windows you need to go through the wizard, but then go back and edit the link manually, and then you have access to all the options. So it still has all the options, just it's a manual process rather than a quick setup. There is, yeah, there definitely is. Sorry, you had a comment or question.
Apple removed PPTP support from their products. I don't know about passing it through, but it just went away. And even the entries, as in if you had to configure on your laptop and you upgraded, it just all went away. So L2TP IPSec is the new standard. It does work on Windows and it does work on Apple products and it does work against the MikroTik L2TP access concentration. So you can get it all to work. My question was about the WP and the intercommunication protocol for NV2. Okay. Wow. So what does NV2 sync use to communicate with the other APs? Is it on the wireless layer or does it need the Ethernet back channel? And you say that there's no GPS required, which the GPS was, we all know what the product that's for, but that's used for mostly for timing synchronization. You get a very high accurate clock source from GPS. So what's used as a clock source, does anybody know, for synchronizing the access points?
Okay,
Is it
I
just
don't know the
internal
answer
one?
to that. As I said, it's still quite an experimental feature, and there's not too much information. I don't know if any of the guys from MikroTik are able to give us any answers yet, but I suspect you need somebody from the development team to answer questions like that.
Okay, and what about, you just said master and slave mode. Does that just use like the neighbors discovery? Do they all need to be on the same L2?
As far as I've seen, they need to be on the same L2 network. Yeah, so they need some kind of physical connection between each other in order to do that.
Okay.
Yeah. So, question over there?
With point-to-multipoint connections on AN, we were able to connect clients further than 25 kilometers away. But with all the AC devices, you can do a point-to-point further than 25, but the moment you do a point-to-multipoint, it doesn't allow you further than 25 kilometers. Any answers on why that is so?
Not actually aware of any limitation like that. So yeah, unfortunately, that's not something I'm able to comment on at all. Just never ever come across it as an issue yet. Admittedly, I'm not running any point-to-multiple clients at 25 kilometer distances, so it's fortunately not come up as an issue for me. But it'll be fixed in version 7.
And version 7 is coming.
Anything else? Okay, thank you very much. I hope it's been informative, and see you next time.
Okay, the next presentation by Hannes Williams.